This video shows how to read out pin number 2 of an I/O link port in addition to the data of your connected I/O link sensor in a PROFINET network. This means that I/O link data and an additional binary signal, such as from a limit switch or proximity sensor, can be read in via a so-called A port of an I/O link master. Let's first take a look at the hardware. Depending on the I/O link master, the information of the additional binary signal is read out differently. Therefore, an AL1300 Dataline and an AL1402 Performanceline Master are used in this setup to show both possible variants. The masters are connected to a Siemens S71200 PLC with PROFINET interface via a switch. As shown, two sensors are connected to one port each. A PN7593 pressure sensor with I/O link interface and an IF5807 inductive proximity switch for the binary signal are connected to port 1 of the AL13004 port master using a Y cable. Before using the software, here's an overview of the pin assignment of the I/O link ports of the two masters. We go to the IFM homepage and navigate to the AL13004 port master online datasheet. Under wiring, you will see the pin assignment of the individual ports. All I/O link ports are so-called A ports. A suitable Y cable is used to read in an additional binary signal, but wiring via terminal blocks or similar is also common. Both sensors are supplied via pins 1 and 3 of the I/O link port. Pin 4 of the I/O link pressure sensor is connected to pin 4 of the A port of the I/O link master. In addition, the switching signal of an inductive sensor, which is also output via pin 4, is connected to pin 2 of the same port. Pin 5 is not used on an I/O link A port. The next step is to check the pin assignment of the other master. Again, navigate via the IFM homepage to Wiring in the AL1402 online datasheet. The available I/O link ports are organized in two groups of 4 ports each. Ports 1 to 4 are so-called B ports, and ports 5 to 8 are A ports. The black-colored B ports use pin 1 and 3 for the supply voltage of the sensor, and pin 4 for the I/O link signal, just like an A port. It is also possible to use pin 4 as a digital input or output if no I/O link signal is used. A B port also allows separate power supply of actuators via pin 2 and 5, or use of pin 2 as a digital output. For this reason, port 5 is used to connect the sensors. As in the previous example, we use a Y cable to connect the I/O link signal from the TR7493 temperature sensor to pin 4 of the A port. We also use an IF5807 inductive sensor for the digital switching signal and connect it to pin 2 of port number 5. Let's have a look at the setup in the TIA Portal programming software from Siemens. As already mentioned, this video shows how to read out pin number 2 of an I/O link port. If you have further questions about communication settings, the data structure of an I/O link sensor, or the necessary programming steps, please watch the corresponding I/O link integration video. We switch to the device view of the Dataline Master AL1300 and assign the required memory space for the pressure sensor to the port number 1 we are using. As the other ports are not required, they are disabled. As can be seen in the catalog view, this master series has one head module and a large number of corresponding submodules for configuring the I/O link ports. It is important to note that the head module does not have its own input or output addresses. The addresses automatically assigned by the TIA software refer directly to the submodules for the individual configured I/O link ports. In addition, the input addresses always automatically contain a so-called PQI byte. After configuring the ports, we go back to the IFM homepage and select the download area for the 4-port master. Open the operating instructions and search for the term Pin 2 using the search function. We quickly find the information that the additional digital input is stored in the PQI byte of the corresponding port. The port qualifier information mapping shows us that the status of pin 2 is mapped to bit 1. Back in the device view, we can see that the input address for port 1 is 68 to 70. We go online and create a new watch table to display all the information at once. The raw data from the PN7593 pressure sensor is transmitted in 2 bytes. To show how the data changes, we choose a binary display format. Bit 0 and bit 1 of the second byte of the raw data are used for the switching outputs of the I/O link sensor and are listed separately here. For the sake of completeness, the pressure value of the sensor is also displayed. As can be seen from the operating instructions, the status of the additional read-in of pin 2 is found in the first bit of the PQI. As a byte for the port qualifier information is automatically provided in the memory area we have defined for the I/O link data, we can address this directly with byte 70. We activate the live view and check the incoming data. First, we apply some pressure to the measuring cell of the sensor. Switching output 1 is switched at 2 bar and switching output 2 at 6 bar. The pressure value displayed in the software is the same as the value displayed by the sensor. Now the inductive sensor is damped and bit 1 in the PQI byte is set accordingly. Back in the network view of our setup, we switch to the second I/O link master, AL1402, with 8 ports. As mentioned at the beginning, the first 4 ports are designed as B ports and therefore do not have the option of reading an additional digital inputs. We therefore connect the I/O link temperature sensor TR7439 to port 5 of the master and configure the required memory size. An additional byte is also provided here for the port qualifier information. As before, the other ports that are not in use are deactivated. Before we look in the operating instructions where we can find the information about the additional digital signal, let's take a look at a very important detail. As the device overview shows, this master already has an input and output address for the head module called I/O link master proxy. In addition to the submodules shown in the catalog view, other head modules are also available. We change to the IFM homepage and navigate to the download area to open the operating instructions for the AL1402 I/O link master. Section 9.3.3 explains how to configure the I/O link master and which operating modes are available. As we have already seen in the catalog view in the TIA software, 3 different modes are available: the standard mode, the I/O mode, or the mixed mode with energy monitoring. As we can see from the table, different memory sizes are assigned depending on the selected operating mode of the master. Scrolling down, we see the corresponding mapping for the so-called I/O mode, which is recommended for compact transmission of digital input and output signals via pin 2 and pin 4. We can also see from the mapping that the first byte of the master contains the status of the digital inputs of pin 2. For the port 5 used by us, this is therefore bit 4. The mapping of the mix mode, which is used when I/O link signals and digital signals are to be used, also shows that the information from pin 2 is stored in the same place in the first byte of the master. And finally, let's look at the mapping of the mixed mode with energy monitoring. This mode is used when both the supply voltage and the current consumption of the connected sensors and actuators need to be measured and transmitted from an energy point of view. Pin 2 information is also stored in the same way. As a PQI byte is also reserved when configuring the port of the AL1402, let's have a look at this assignment for comparison. As you can see, the PQI is structured differently and no longer contains any digital signals. Back in the TIA portal software, we can see that the AL1402 is in energy monitoring mode, and the input addresses for the master are 1 to 36. We also note the input addresses 71 to 73 for port 5, where our I/O link temperature sensor is connected. To present all the values in a clear table, we will also create a new watch table online. Again, the raw data from the temperature sensor is transmitted in 2 bytes and displayed in binary format. Bit 0 and bit 1 of the second byte of the raw data are also used for the switching outputs of the I/O link sensor and are listed separately here again. For the sake of completeness, the temperature value of the sensor is also displayed. For direct comparison, the PQI byte of port 5 with address 73 is also listed. As we have seen from the manual, the status of the additional digital signal of pin 2 is found in bit 4 of the first byte of the master. We activate the live view and check the incoming data. First, we touch the probe of the temperature sensor. Switching output 1 is switched at 24 degrees Celsius and switching output 2 at 25 degrees Celsius. The current temperature value shown in the software also corresponds to the value displayed by the sensor. Now the inductive sensor is damped and bit 4 in the first byte of the so-called master proxy settings is set accordingly. As the PQI byte is assigned differently here, nothing changes there. To summarize, if a new I/O link master is added and the master module itself does not receive its own input and output address from the TIA software, then the status of pin 2 is stored in the PQI byte of the port. If, on the other hand, a new master has its own input and output addresses, the status of pin 2 is stored in the first byte of the input address, regardless of which operating mode of the master is selected. Thank you for joining us.